Okay, question 12, we got a trig identity followed by a lovely trig equation. So part A, 3 marks, answers to prove that 1 minus cos of 2 theta is identical to tan of theta sine of 2 theta, where theta is not allowed to be 2n add 1 pi over 2 and n is an integer. Okay, so with an identity, never start with both sides. Start with one side, see if you can do any magic to turn it into the other side. If not, try turning the other side into the first side. If that makes sense. My brain hurts. Okay, so let's start with the left and see what magic we can do. So 1 minus cos of 2 theta. Well, we know that cos of 2 theta is cos squared minus sine squared. So let's plug that in, see if that's any good. So we got 1 minus cos squared of theta add sine squared of theta. Okay, because I'm old, 29, I already can't remember what we're trying to show. So we need a tan and a sine to theta. Right, so we don't want any cos terms anywhere. So let's now use sine squared add cos squared is 1. So cos squared is 1 minus sine squared. So let's put that in. So we now got 1 minus 1 minus sine squared add sine squared. So that's going to give us 1 minus 1, so they cancel out. We're going to get left with 2 sine squared theta. Now, that is not ideal, but remember we want a tan. So, what we can do is to get ourselves a tan. Let's first of all think of this as 2 sine theta, sine theta. Now, we can multiply a number by a 1 without making any difference. So, we can multiply a number by 1 in a clever way. We're not really making a difference, but we are making a difference. Stop being cryptic, mouth. Okay, we can multiply this by cos theta over cos theta. Now that's going to give us 2 sine theta sine theta cos theta over cos theta. Now, we can say then that we've got 2 sine theta cos theta times sine theta over cos theta. And then, as if by magic, we have our identity. 2 sine theta cos theta is sine of 2 theta, and sine over cos is tan of theta. We've proven it, we feel clever, let's put a cheeky little QED, quite enough done. Okay, then part B for 6 glorious marks says hence, so that means we're going to be using what we did above. Solve for x between minus pi over 2 and pi over 2, so radians. The lovely equation sec squared minus 5 times 1 minus cos of 2x is equal to 3 tan squared x sine of 2x. Give any non-exact answers to 3 decimal places. Okay, so check out what we have here. 1 minus cos of 2x, and that was the left hand side of this identity. So we can say then that we are actually solving sec squared x minus 5 times tan of theta sine of tan of x sine of 2x is equal to, now we got 3 tan squared x times sine of 2x. Okay, so before we do anything else, we can actually get a solution from here. We can see that both sides have a factor of tan x and sine of x, sine of 2x. Now, tan and sine are both 0 when x is 0. So, our first solution is x is equal to 0. So, now we need to get any others. So moving forward, we're going to need a trig identity, and that is that sec squared is equal to 1 add tan squared. So, if we substitute that in, we're going to get, in this first bracket, 1 add tan squared minus 5. So we're going to get tan squared minus 4 times tan x sine of 2x is equal to 3 tan squared sine of 2x. Okay, now let's get everything on the same side. So we can also, actually, no, let's not do that. Let's get everything on the same side. Tan squared x minus 4 times tan x sine of 2x minus 3 tan squared x sine of 2x is equal to 0. Now, it might be tempting here to divide common factors away, but we can't do that because we may be dividing by 0. So what we do instead is factorise. So our common factor is tan x sine of 2x. So we can say that we got tan of x sine of 2x times tan squared x minus 4 minus 3 tan x. Is equal to 0. Now, we've got the solution that comes from this bit. That just gave us x was equal to 0. So, all that we now need to concentrate on is what's going on in here. So, this is a quadratic tan squared x minus 3 tan x minus 4. We need that to equal 0. So, hopefully we can factorise this. Yes, we can. So we get tan x minus 4 times tan x and 1 is equal to 0. So that now gives us two separate equations to solve. First one is tan of x is equal to 4, and the other one is tan of x is equal to minus 1. So let's do this chap first of all. So we get our first solution by doing x is the inverse tan of 4. Now that is going to give us, remember to put your calculator in radians, so we're going to get 1.326 and the other one is going to give us, so if we inverse tan minus 1, we get minus 45 degrees, which is minus pi by 4. Now that is all of our solutions. Remember, we're solving in the range x is minus pi by 2 to pi over 2. So we are only going to get those three solutions. So x is minus pi by 4, 0, and 1.326. Good times.